Hello everyone and welcome to the session about behavior-driven development. My name is Paweł and you might know me from organizing a thing that is called Mobile Warsaw, which is a mobile developers meetup in Warsaw, and I also do a thing that is called Mobile Academy, which are workshops for advanced workshops for iOS developers. And today, again, we'll talk about behavior-driven development. And first of all, I'd like to say thank you to the organizers for inviting me here. I'm having a great time, and I hope you're having a great time as well here. But before we go into the topic of behavior-driven development, I'd like to ask you one very simple question. What is a unit test? So usually when I try to learn about a new topic, I go to Google and just type whatever I want to know about into Google and see what it throws out. And usually throws out a web page that's pretty popular with developers, which is called Wikipedia. So this is what I did with unit tests. And this is the definition of unit tests from Wikipedia. Can you read it? No? Yes? Should I read it out? Please don't make me do it. So if I had no prior knowledge to what unit tests are and I'd read this, I'd probably go like, what? Let's do some experts. Individual units of source code, modules together with associated control data, usage procedures, operating procedures, what the hell? Like, I would have no knowledge about unit tests after reading this. So in the beginning of this presentation, what I'd like to do is to arrive at a better definition of what unit test is. But to do that, we need to answer a more profound question, which is, what is an app? I need examples now. Who knows what an app is? Excuse me? No? Anyone, what is an app? Yes, but let's try developer's perspective. What is an app from developer's perspective? Yes, job, money, yes. Those are correct answers. Yes, input-output is a little bit closer. For me, from my perspective, an app is always a set of behaviors that we as developers created and that are somehow expected by the user. There is, of course, lots of other people like designers, QA guys, UX guys, tons of people who help build this app. But ultimately, it is as developers who build the app, who created the behaviors in it, and then there are the users who use it. And I let that hang for a while, and I'll tell you something a little bit controversial, that we programmers have a limited cognition, like all humans do. We may say that, we're smarter, we can remember more, we can learn more, but that's not true. We're just normal people. And that means we can't always load all the code that our app is into our memory when we're working on it. Remember that an app is a set of behaviors, but it's also hundreds of thousands of lines of code that you need to load in your memory when you're working on an app. And that, unfortunately, means that by accident, you can change something in your app and break it. And there are a few scenarios in which this can play out. The first scenario is pretty good, where you just notice when you're working on the app, because then, hey, I just made a mistake, so I'll fix it, and everyone's happy. The other problem, the next scenario, is when this goes to QA, and QA catches it. But then you wasted your QA's time to find bugs on old features, because let's assume that you implemented a new feature, and it broke an old one. And then the QA has to test that old feature, which was working, so why test it? And then after, I'm not sure how does it work with QA departments at your companies, or whether you actually have QA departments. If not, that's horrible. And for me, there's usually a week of delay after I get a bug report on something that's broken, or sometimes more. And after a week, I'm pretty not in the context of what I did a week ago. And then I have to get back into the context, remember why I did this this way, what does this piece of code that's broken do, and what was it supposed to do. And everything like that is taking your time. You could have been working on new awesome features for your app, but instead of that, you're fixing bugs, which you should not be doing. There are two scenarios other than those ones which can happen. This can go out to your client, and the app might crash on them, and maybe they lost their precious data, I don't know, photos of their children. And they get pretty pissed, and they move to a different product and stop buying your apps. And this generally is a complex problem of preserving behaviors in apps or in any systems at all. Even for simple ones, you might be having a bad day. Maybe you're hungover, or maybe you just didn't sleep well. Weird things happen. And you made a mistake, and you broke something. Fortunately, we programmers are good at solving issues and finding tools to make sure our lives are easier. So we came up with the idea of unit tests. And finally, we arrive at a better definition of a unit test. A unit test is a fail-safe that makes sure all behaviors in your app are preserved. Mathematically speaking, it's a proof that everything works as you expect it to work. And what is the usual approach to unit testing at most of the companies that I know of? Who needs unit tests anyway? This is not the best approach. I think you already understand why this is bad, so let's not go into details. The other approach that I heard about or hear about quite often is let's just write tests afterwards, not focus on tests now. And let's focus on this approach for a second. If you don't write tests while you write code, you're not using something that is called a test harness. Who knows what a harness is? Raise your hands. Everyone else, don't worry, because I also use Wikipedia for this definition. I like Wikipedia, as you can tell. So a harness is that thing that construction workers who work on high altitudes put on themselves, which has a rope attached. So if they fall, they don't die. Or when you have small children, you can attach also a harness to them and a line so that they walk in, well, they don't run away. Or you can use them for horses to make sure that you can steer where the horse goes so you don't die when the horse is mad and wants to escape. Anyway, generally speaking, a harness is something that is supposed to protect you. And it is the same with tests. It is something that is supposed to protect you from tripping over and making mistakes. If you're writing a new feature into your app, you might think, I'll just write tests for that afterwards. So everything will be fine because I'm not touching the old code. But that's not true. You need to integrate this new feature with existing part of your app. And the integration point might break. And if you don't run your tests, if you don't write new tests when you're doing that, you don't know that you broke something. And it might turn out that at the end of the implementation, you run your test and, oh shit, this won't work. And you need to rewrite everything, and that's just, well, waste of time again. And another scenario is when you work on a feature and you're sort of in the middle of your work. Everything is fine, everything works, and you didn't write any tests for it. And you started the next part of the feature and you broke everything. And you didn't know because you had no tests that would tell you that you're doing something wrong. With tests, you would know instantly that there is a problem. And you could adapt and you could take a different path. Another thing that's super cool about writing tests first is that they are a super cool heuristic guidance to writing software. This is my favorite quotation on test-driven development or tests in general. Any ideas how old it is? It is the Dijkstra, the guy from the algorithm. Anyone? How old can this be? I think 40, 50, yeah, something like that. So pretty old. Older than I am. And they knew about this 40 years ago, and still not everyone is doing it. And for me, it's a super great way to work in software, and I can just focus on smaller parts, implement a very small part, and then move on, move on, move on. And the sum of all parts is usually more than I'd implement if I didn't do that. And in this heuristic guidance, you get this approach that you write a failing test. You make it pass. Or you could say that you have red, green, and people who are familiar with the matter would probably now add a word refactor, which is super important part where you have all your test harness and you can focus on making sure that the app still works, but the code is better. And this is actually how test-driven development is born. In test-driven development, you always write test first, always, no exceptions. And then you make it green by writing or refactoring existing code. However, if the only thing that you're doing is writing test first, you're not doing TDD. You're doing it wrong. You're just writing tests first. Because TDD is a great way to determine how complex your code has become. All you have to do is just listen to what tests are telling you. Do you have to fake 7 objects to isolate one of your test cases? Do you have to inject a fake into a fake into a fake? Or perhaps your setup method has 70 lines of code. All these things point to one thing, overcomplicated design. And your tests are here to tell you. If there would be one thing that you'll remember from this presentation, one thing, please let it be this sentence, or actually 2 sentences. All behaviors are testable. The only thing that is not testable is the code that you write. Everything is testable, believe me. The only thing that might not be testable is how you're writing your code. For instance, if you're having problems with writing tests for an object, it probably means that you're not sure about the requirements for this object, and perhaps you need to rethink your architecture, which is super cool because if you didn't have that, you'd probably write that object, but you still didn't know what are its responsibilities, what exactly should it do. But tests enforce that. You have to do it prior. So there is no point where you end up with bad code, with code that has vague responsibilities, because tests enforced that you have to understand what you're trying to do. Moreover, this is super cool. You're becoming the very first consumer of your API, even though the API is not yet implemented. So we can tell that, damn, this API is shit. I have no idea how could I think that anyone could use it. And you get this unique moment when you can think, okay, I don't think I want to implement it this way, because using it will be horrible. Or perhaps usage might be okay, but then if you're having problems with writing tests for an API, then probably it'll be hard for other people to understand what does this API do, and it will be hard for them to change it in the future. And as said, by writing tests first, you're forcing into thinking what responsibilities given object has. And because of that, you'll end up with a more think-through architecture of your app. And let's sidetrack a bit. Usually when I go out to conferences and say that I do full test-driven development all the time, I get lots of questions. Hello. Just a little bit late. I get lots of questions. How do you do this? I tried doing this, but I don't know how. I have problems with starting. And from all the questions that I get, there are usually 3 very distinctive ones that everyone asks. And those are, what should I test? The question is, how can I start? How can I write my tests so that they make sense? What functionality should I test? How to explain what is being tested. I'm pretty sure this is also a common case with you. You have a problem, you thought, okay, I'm going to test this, but then how do I express myself? How do I express what I want to test here? And again, which is somewhat similar to the previous one, how can I clarify requirements for the object that I'm trying to test? How can I easily write in code or in any easily understandable language, what am I trying to achieve here? What is the thing that I'm trying to test? And if you have questions like this, don't worry. It's not a problem. Or actually, it is a problem, but most of the people have this problem. Everyone had this problem at some point. And this is, generally speaking, a problem of test-driven development. It gives you an awesome tool to build architecture of your app, but it doesn't tell you how to start. It's easy to say, I'm going to sit down now and I'm going to write tests. I'm going to test the shit out of my app. I'm going to test everything. And then who tried that? Who tried that with no experience to test prior? Okay, did you have problems with starting? Exactly. I remember my first unit test that I wrote after about 2 weeks when my CTO was telling me, you have to write tests, you have to write tests. The first test that I wrote was checking whether a singleton is a singleton. Sounds awesome, right? Of course, it passed, right? And that was horrible. Don't do that. Those are not real tests. And so it's hard. It's hard to start. There are not that many materials out there which can help you. And truth is that this was a problem from the beginning, but experienced people already had an answer. The people who did test-driven development for a long, long time, they knew what to do, how to do it correctly. They had a set of unwritten rules how to approach test-driven development to make sure that you know how to test, you know how to express your requirements for objects. And this is exactly how behavior-driven development was created. And behavior-driven development is super simple. Believe me, it's super simple, but it requires a shift in how you perceive your tests. Most of the people, when they think tests, okay, so I need to test something, so what do I do? What does exactly testing mean? Don't think about tests when you're writing tests. Best thing you can do to yourself when writing tests, think about examples. Think about behaviors. Think about examples how your objects should behave. This is the quintessence of what your test should be doing, making sure the object behaves as I'd expect it to behave. And of course, how do we define object's behavior? We define it by the methods that it declares in its interface. That, and of course, its dependencies, but nothing else. You should never, ever, ever touch internal implementation of your object when testing. If you're doing that, you're doomed. You already failed. That's not the right approach. Why? Well, let's say you want to change something in your code, in your internal implementation of one of the classes in your app. If your tests are super tied to that implementation, you have to go and refactor the test as well. And that's not the point of tests. The point of tests is to help you, to make sure you can do everything inside that class, rip it out completely and write it from scratch. And your tests should still pass. In behavior-driven development, people name this working outside in, where you start from the business level of the feature that you're trying to build right now, and you go down, 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 down when you find the smallest component in your app, the smallest class in your app, and you test that, but only in its interface, not internal implementation. There's actually a story related to that. As you already heard, I also do workshops, and I once done workshop in Belarus, and there was a guy working, it's a messaging app for iOS, but I don't really recall the name right now, and he told me that they're having lots of problems with tests. And the problem is that each time they change something in one of their classes, they need to go and change tests. So they help them somehow, but it's more of a burden for them. And so I asked, how do you do your tests? And he said that they have for those of you who do, who does iOS here? Okay. So there's a header and implementation file in Objective-C, and they did that all in Objective-C. And what they did, they had a special script set up that went into each and every class, into its implementation, and generated categories so that each and every method was available in tests. And that's how they tested their objects. And when I saw that first, I thought, hey, no wonder you're having problems. So if you want to do that, don't. Your tests will be more of a burden rather than helpful. And of course, you should use ubiquitous language to describe what you're testing right now. And this is one of the most cool features of behavior-driven development, is that it tries to somehow simplify the way you write tests so that it's easier for others to read. And let's take a look at an example. There will be no live coupling, don't worry. And my all-time favorite question, can you see my screen? Can you read it? I hear yes and no, so I'm not sure. Needs to be bigger, okay. I think I can make it bigger by just pressing this thing. Oh, come on, Xcode. Apple quality software, people. Is it big enough? Okay. And now my Xcode is, there we go. Okay, so most of the questions that I get about behavior-driven development is how, no, the first question that I get is, do you test your view controllers? And I say, yeah, why not? And then the next question is, how do you do that? How can I test view controller? It's tied to view. And my usual answer is just treat it as normal object. That there's no magic behind writing tests for view controllers. And today we'll see two approaches that you could do to testing view controllers. One that is a path down to hell and will make you burn sooner or later. And the other one that will give you quite nice results and will make your life better. As you can tell, this is in Swift. I had real problems with writing tests in Swift for this example, but everything is okay now. I won't compile test because Xcode apparently doesn't catch all the errors and it looks like everything's passing even though it's not, so let's just assume it's as it should be. Yes, Swift. So this is a super simple view controller which takes a photo uploader object, which is just a super simple protocol that defines one function, upload photo. And of course, it has a success block. In our init, we just pass the photo uploader, equals super, we add a title, and we add just a simple right bar button item, where we will just add a target and selector. And then in the did tap right bar button item method, we just call the photo uploader with empty UI image and no success block at all. And now when we go to tests, we have a fake photo uploader class here defined. Oh, let's start from top. We'll use quick and nimble for behavior-driven development style DSL in our specs, and we'll use nimble for test. Who is familiar with quick or nimble? Who is familiar with behavior-driven style tests or RSpec? Not bad, but that's good. You'll learn a lot. And this class is, our fake photo uploader is super simple. It just flips a switch that, hey, this was called when we call the actual method. We also use testable import for our mobilization 2015 module. I really don't like the way Apple did this because now I can call all the private methods on every class in mobilization 2015 object classes, which sucks. But the other option is to make everything public, so I'd rather do this. And then when you want to do a quick spec, spec stands for specification, which is a different name for tests. When you want to do a spec for one of your classes, you just inherit from a class that is called quick spec. And you need to override a function that is called spec. And in that function, all the magic happens. We start by defining two variables. SUT stands for system under test, which is a standard way to describe objects that are being tested right now. So if you ever go into someone's tests and that person knows how to test, you'll probably see that name. And it's a way to describe universally that this is the thing that I'm testing here. We also have our fake photo uploader. And let's focus on this block here for a second, or maybe let me not select it. So what this block does, this it here, it's actually one test that we're going to run. And what it does, it takes our system under tests title and compares it to photo upload, which is the name that we're expecting here. Of course, this is a very trivial test, one that you might not write in production, but it's a great example how airspec style tests look like. Then next interesting thing that you have here is the before each block. As the name suggests, a before each block will be called before each and every test that is defined on the same level. So the order of execution in our case will be first for this test, we'll first run this before each block when we create our fake photo uploader. And then we create our photo upload view controller, which is our system under test with our fake photo uploader. And then here we take it, we check its title, whether it works correctly. Is that understandable? Yes, no? Great. There is actually one thing that should be added here that I totally forgot about. And we should add an after each block, which, as the name suggests, is run after each and every test. And we do this. Any ideas why? Yes? Exactly. That's actually a very popular issue that people are having, and they don't know why. So if we didn't do this, and we had another test here, then the object that we tested in this test will be deallocated in before each block for the next one, because we just replaced the variable and it's gone now. And it might seem like a trivial thing, but consider this. You have a very specific test case which does something where your app crashes on the alloc, or the object crashes on the alloc. And now you think that that crash is happening in a different test. And that sucks. Of course, you'll probably quickly see that what happens, but then you wasted 2-3 minutes to understand what's going on, and you could have avoided this by just writing 3 lines of code. So let's try something more complicated. And we'll add a describe block with a little bit of non-behavior style tests. And why is there, okay, it's just Xcode's following. Quality software. So a describe block is a little bit syntax sugar slash actual functionality. It's used to aggregate similar logic in one block. So here I'm saying that I'll be testing right bar button item, and I just grab that right bar button item in before each block, and I do some assertions on it. And of course, this before each block will be run for this, and this test only. And the before each block that we saw before, the one where we created system under test, will of course be run before this, before each block. So the order of execution is from top to the bottom. Is that understandable? Any questions at this point? Does anyone feel confused? Horrified? You want to run away? Not yet? Cool. So let's go quickly through the tests that I wrote here. The first one is super trivial, but it might save your ass from time to time, which is we're checking whether our bar button item actually exists. And we're doing that by not just saying, I expect this to not be nil. We're saying that, okay, want this to be of specific class. And why do I do that? Why do I check for a specific class? Well, it might happen that you made a mistake. In Swift, it's less possible, but in Objective-C, it was more possible, where you assigned wrong object to this place. And then your test might go a little high-wire, and you won't know initially what's happening. But here, you instantly see, OK, I expected this to be a bar button item, but it's a UI view. How that happened, I don't know, but your test would tell you instantly. Next, I'm checking whether my right bar buttons item target is our system under test, which is the photo upload view controller. And then, of course, I'm checking whether the action of our right bar button item is equal to the selector that I previously declared. And then, when we want to test the actual action in another describe block, because we're testing something different right now, we grab the bar button item, and since we use the almighty add testable import, we see everything in the implementation of that class, so I can just call dittap right bar button item with that bar button item, and I check whether my fake photo upload or photo upload was called, because I expect that the flag in the fake class that I prepared was flipped. Is that understandable? Yes? Do you see the problem here? What's happening? What's so wrong with this approach? Yes, exactly. So even though this is testing something, it will be a pain in the ass to refactor that class right now. I would not like to have tests like this. In fact, I would probably just delete everything except the one where I test whether my bar button item actually exists. Because these two, this one and this one, they're horrible. If you're writing your tests like this, you're doing it wrong. Remember how we want to approach our tests. We want to work from outside to inside. And looking from outside, the behavior of our item is like this. When I tap the done button, I want this to be called. I don't really care what happens under the hood. The only thing that I care about is that this gets called. Whether there is a block involved, whether there is a closure, additional objects in the way, internal helpers, I don't care. I only care whether this gets called. So let's quickly see how this would look like. It's also way shorter, right? So I define, again, a describe block where I say I'm testing right bar button item. I get the bar button item. I, of course, check whether it exists. And then I use a magical helper function, which only calls target with selector, with action. It doesn't really care what the action defines. And I check whether my fake photo upload or photo upload flag was flipped. And now, see, I have two tests. Previously, I had 4. I get better tests because, well, they are not fragile. They won't break if I change the internal implementation. And they do the same thing. Even better because they're not fragile. Any questions? It uses the same thing the system uses to tap. So what it does, we can see how it looks like. It just grabs target and casts it to an NS object. Because if you want to do perform selector, which is done underneath, it has to implement. It has to be an NS object. Then I grab the action, and if the target actually exists, I perform selector with that action and the actual bar button item, which is the exact same thing system would do. But there's no way to actually call this the way the system does. I'm pretty sure that's what they do underneath. So. And I also encourage you to write lots of helper methods like this, because they'll make your life way easier. So we're slowly approaching the end of this presentation, and you might think that from what I said, the behavior-driven development is awesome. I'm going to go out, I'm going to do behavior-driven development all the time, and my life will be easier. I won't ship any bugs. I'll live in developer's wonderland. Unfortunately, that's not true. Sorry to break it. Behavior-driven development never guarantees that you won't ship a bug. Unit tests never guarantee that you won't ship a bug. But they will be goddamn good at reducing the amount of bugs that you'll ship. And even if you ship a bug to one of your customers, you can write a test case for it and make sure it never happens. So it's a great tool to make sure there are no regression bugs. And from my experience, working without any test-driven development approach back in the days 2 years ago and doing that full-time now, most of the bugs that we get are misuse of Apple's API, sorry for that, Apple, or misunderstanding of what Apple meant. And those are the usual crashes that we get or usual bugs that we see filled by customers. We very rarely get crashes due to something that we incorrectly did because we have test cases for that, which will tell us instantly. So, quick recap. Behavior-driven development. Think examples, behaviors. Don't think tests. Provide examples how your objects should behave. And don't test implementation, work outside in. Focus on the smallest components in your code. And use ubiquitous language, the one that you just saw with before each blocks and it blocks and after each blocks, to make sure every team member understands what are the requirements. And your benefits, you'll end up with a cleaner, more robust, and just more beautiful code base with less bugs and more time for fun features.